This video is going to be on doing current ramping on a fuel pump. So I'm going to show you how to check the current as the fuel pump is running so that you can, and then we're going to talk about how to analyze the waveform. So we're going to be using the Picoscope to do this, and we'll also be using the 2000 Ford Ranger that we've got here in the shop. So let's go ahead and get started. So first of all, we'll talk about the tools that we're going to be using. The Picoscope is right here, and so we're going to be using one channel of the Picoscope. We're also going to be using a inductive amp clamp, and this one is a 60 amp clamp, and it has a setting for 20 amps or 60 amps. We're going to be using the 20 amp setting on this. The other thing that we're going to be using is we're going to be using this kit here, which is a relay bypass switch kit, which makes it really easy to check the fuel pump for operation with an amp clamp. So the way it works is you have a relay that you can, it's actually it's a tool that you can replace the relay with. So the fuel pump relay has a 5-pin relay in it, and these 2 pins that are on this tool, they go to the positive and ground for the fuel pump. So it's basically like bypassing the relay. And then it's got a loop of wire right up here on the top of the tool that once you plug that in, all you have to do is clamp your amp clamp around that wire and you can read the amperage. So you don't have to worry about blowing fuses in your fluke meter, because we're not going to be using the fluke meter in this scenario. So I'm going to go ahead and hook everything up, and then I'll show you what we've got. So here's the relay center on this particular vehicle. So what I'm going to do is I'm going to pull the fuel pump relay, which I had to look it up on service information to figure out which relay it was. And if you look, this is a 5-pin relay, and so those 2 big terminals right here are the ones that we're going to jump across with the amp clamp tool. So these are the same 2 terminals on those. So, and they're basically just hooked up to this red wire. So I'm going to go ahead and plug this in. And then on top of this relay, before I plug it in, I'm going to show you this on top of this relay. There's a switch. So once this relay is plugged in, all you need to do is just flip this little switch to on and turn it off to operate the fuel pump. So it's going to be in the off position, and then we'll slide this relay into place. So there it is. And now we'll hook up the amp clamp. And when you hook the amp clamp up, on this, there's a setting right here. So you flip this on, and there should be a battery light that shows up right here, and it should be green. So once you turn it on, we're going to read the 20 amp scale. So we're going to bring it down to 20 amps. And before you click it on, or before you clip it on to the wire, press and hold the 0 button for a second or two, and that zeroes out the amp clamp. And so now it's ready to go. So we can just hook the amp clamp right onto our tool, and I usually set the amp clamp off to the side a little bit so there's no other electrical that interferes with it. And so now I've got my amp clamp hooked up to my tool. It's ready to go. So now let's take a look at the software on the computer. I want to show you a couple of things with that. I've got the Pico software open, and it's operating now, and I want to show you something that I learned over the last couple of days. I was trying to make this video demonstration for you, and of course I was following the instructions that I gave you, which means that you come up here to the automotive soft key right up here at the top of the screen, and click on that and drop it down and go to actuators, and here's the fuel pump test right over here. But what I've discovered is when you click on that fuel pump test, what the Pico software does is it opens up a preset program that has all of the calibrations and everything preset in it, and you can't change them. And unfortunately, with this particular exercise that we're doing, it only showed me the top half of the amperage signal. It didn't show me the negative half of the amperage signal. And so it was really frustrating to me. I was trying to figure out why it was doing that. And what I came up with is setting the machine up manually. So we're not going to use the automotive drop-down menu this time. What we're going to do instead is we are hooked up to the channel A on the oscilloscope. And so I'm going to come over here to this little box that is the channel for A, and I'm going to click on it. And right here where it says probe, I'm going to choose what probe that I'm going to be using. So right now it says X1 probe. And what that is, that's just your regular meter lead that we've used in the past for back probing sensors and whatnot on the picoscope. And so I'm going to be using an amp clamp, and I'm going to be using a 60 amp clamp. So this is the clamp that I'm going to be using right here. It says 60 amp current clamp in the 20 amp mode. And so that's the tool that I'm going to be using. So I'm going to highlight that. And so now it says it right up here, 60 amp clamp. And then if you expand that, it's going to tell you that it's in the 20 amp mode. And so I've got that set up. So now what I'm going to do is I'm going to go up here, and if you notice on my settings up here, it's going to capture from -5 to 20 amps. So it'll capture the bottom side of the signal and the top side of the signal. And I'm in the DC coupling, which is what normally we use. Typically we use the DC coupling. And we're at 20 milliseconds. So we might change the 20 milliseconds depending on what kind of signal we get. We can increase it or decrease it depending on the size of our signal so that we can see it better. The other thing I'm going to do is I'm going to turn off these other channels, so I don't have to see 4 lines going across the screen. So I'm going to go over here to the B channel, which is in red, and you click on this blue arrow that's right next to the volts per division, and you highlight that or click on that, and it'll give you a drop down. Maybe. Sorry, it's not the blue arrow, it's the one that's kind of grayed out. So I'm going to click on that, it gives me a drop down, and then I'm going to turn it off. So, and if you notice, one of my lines disappeared down here on the bottom. So I'm going to do that with the other 2 channels as well. So the channel C is in green, so I click the gray arrow and turn it off. And then D is kind of the yellow channel, and click the gray arrow and turn it off. So now I'm left with 1 channel going across the scope. So now I can come down here to the very bottom and I can start my trace. So I'm going to hit Start Capture, and I'm going to turn on the tool that I have on the amp clamp. Now if you see that, it's reading the amp clamp, but it's not doing a very good job of reading it. So we can come up here and we can adjust our milliseconds per division. There we go. So I got it down to 5 milliseconds per division, and that gives me a pretty good signal. If I want to make it bigger, I think I can do. So if I want to make it bigger, what I want to do is I want to increase my volts per division. So this is going to be, actually in this case it's amps per division because we're not measuring voltage. So what I did is I just increased it to ±5, and what that did is it made my signal a little bit bigger. Now if I want to analyze this, what I can do is I can come down here and I can push the green arrow again down here at the bottom and freeze it. So that stops it, and I know my capture is stopped because these numbers stop moving. So now I can go ahead and turn off my fuel pump so I'm not draining the battery on the car, and I can analyze this signal. Now remember, this is a fuel pump that the vehicle is not running. And so what I'm looking for is I'm looking for any abnormalities in this fuel pump. And if you notice, I've got a flat spot here, a flat spot here, and a flat spot here. I've got a couple more that are starting to show up, but this one here is really prominent. So is that one. That one there is pretty prominent. What that is a wear spot in the armature on the fuel pump. And so this tells me that the fuel pump is probably getting a little old and it could be failing. And if you remember, we use this same vehicle for doing our fuel pressure testing, if you've watched those videos, and we were having some issues with some of the fuel pressures that we were seeing, which could definitely, relate to this right here. So what I want to do now is I want to go ahead and start the vehicle, and we'll look at the wave or the pattern after the vehicle is started. So I'm going to go ahead and start my capture again, and I'm going to turn the fuel pump on. So my fuel pump is on. Now I'm going to start the vehicle up, and we'll see what the amperage does when the vehicle starts. Because really what you want to do is you want to actually analyze this while the vehicle is running. And so I'm going to go ahead and stop it and capture, and so that we can analyze the signal. So I freezed it. And to turn the vehicle off, all I did is I turned off the fuel pump with a little tool that I have on there. So now if we look at this, you can see the amplitude changed a little bit, but we've got more of these flat spots showing up on top of the signal. So that tells me that when the fuel pump is actually running, it's got some other issue, or some of the issues that it has. It's a little more obvious that there's some problems with this fuel pump when the engine is running. So anyway, that's all a current ramp is. So doing current ramping on a fuel pump, this is the test. So just to recap, what we did is we replaced and I'll kind of walk you through it with the video. We replaced the fuel pump relay. We replaced the fuel pump relay with this tool right here, and then we put an amp clamp around the wire. We set the amp clamp to 20 amps. We zeroed it out, and then we clamped it onto the wire. And then when we went to the software, instead of using the automotive drop-down menus on the software, what we did is we set it up manually. If I can get my camera to stabilize here, we set it up manually right here on channel A. So we dropped down channel A, and we chose the amp clamp, the 60 amp clamp, so 60 amp current clamp. And then what we did is we changed our settings to plus or minus 5 amps. We changed our setting up here to 5 milliseconds per division. And then we started our trace, and this is the signal that we got. So that's it. Well, hopefully this was informative for you, and we'll see you in the next video.